Hello students, this is a question recently asked in an exam. The meaning of this question, first let us understand this question. Okay, it is saying function, the domain of function is 0 to infinity, the codomain is 0 to infinity, that is function is positive, entirely positive, be a differentiable and surjective function, and f of x is antiderivative of small f of x, okay, such that this is the relation 2 times of capital F of x minus small f of x equal to f square of x for all positive reals. Then we have to check these 4 options, in which the first option is limit x tend to infinity f of x upon x equal to 2. For this same, the value is 1 in the option B. Then C option is asking about f of x is strictly increasing, and the D says can't be set. Okay, so let's understand this question. First, f of x is antiderivative of small f of x. This means if we integrate this f of 0 to x, we are going to get capital of f of x. This is the meaning of this statement. Okay, so in this given relation, we will substitute this in place of this. Okay, so let's do this. 2 times 0 to x small f of x, f of t, dt minus small f of x equal to small f square x. This is the given relation. Okay, so first differentiate this relation. Let me correct it. Okay, so differentiating this relation with respect to x, let's see what we are going to get. After differentiating, we are going to get 2 times of f of x minus 2 times, and the differentiation of f of x is f dash of x. So we are left with 2 times of f dash of x, and the differentiation of this in the right side of this relation is 2 times f of x into f dash of x. Okay, this is the relation we have got after differentiating the given functional relation in this question. Okay, so first I'm thinking about, as the C option is asking about the strictly increasing or strictly decreasing behavior of this function. So first let us separate f dash x from this relation. Let's see what we are going to get. Okay, after we take common f dash x from this relation, I am going to get f of x upon 1 plus f of x. This we are going to get after solving this relation. Okay, now the sign of f dash of x, as it is entirely positive or it is entirely negative, we can understand by going through this point, that function is giving 0 to infinity values. So if function is going to give 0 to infinity values, then this value is entirely positive. Now this value is entirely positive, in which 1 we have to add, so this is entirely positive. So the function is, as we have got f dash is 0, f dash is greater than 0, so f of x is strictly increasing. So C option is correct. Now let us check about A and B. Okay, let's see. As we can see that function is entirely increasing, so for infinitely bigger value of x, we are going to infinitely bigger value of f of x also, as function is entirely strictly increasing. So let's check what we are going to get in option A and B. So let's take this. If x tend to infinity, f of x upon x, let us think x is tending towards infinity. If x is tending towards infinity, then the numerator is infinite And as f of x is entirely increasing, strictly increasing function, then for infinitely bigger input, f of x will also give infinitely bigger output. And also function is 1, 1 and on 2. So this is nothing but a infinity by infinity form. This is nothing but a infinity by infinity form. In this, we can use L'Hospital rule, as it is applicable in two forms, that is 0 by 0 and infinite upon infinite form. Okay. So, applying LH rule, we are going to get f dash of x upon 1, and this will give us the value of this value what we are going to get in option A and B. Let's substitute f dash of x from the relation we have got there, which is equal to limit x tend to infinity f of x upon 1 plus f of x. Okay. Now take common f of x from numerator and denominator. We are going to get 1 upon 1 plus 1 upon f of x. And as x tend to infinity, f of x is also tending towards infinity. So this value will be equal to almost 0. So the value of this limit is exactly 1. So option B is correct also. So the answer of this question is B and C both. Thank you.